Hello students, today we will study about power of lens. Let's study then. As you can see here, I have drawn two lens. The first lens, that is lens 1 and the lens 2. If you observe, then the difference between these two lens is about their thickness. The first lens is very thin and the second lens is thick. Now, when a parallel ray of light passes by this lens, then they will converge, of course, because the nature of the lens is a converging lens. It's a convex lens. But children see that in both the lens, the difference of the convergence is somewhat different. In the first lens, since it is a very thin lens, the convergence is very less. That means the degree of bending of light ray is very less. Whereas in the second lens, the degree of convergence is quite high, and therefore the parallel rays meet very close to the lens. You can see in both of the lens, right? So in the first lens, you can see this one, the degree of convergence. See the bending here, the bending is very less, and here the bending is quite much, and therefore this lens, that is lens 2, is bending the light rays more than the lens 1. Let us see for the concave also. See, I have drawn here a concave lens, and here a concave lens, two lenses are drawn. Lens 1 is a thin lens and lens 2 is a thick lens, and when the parallel rays come, they diverge because these two are diverging in nature. But in the first lens, the degree of divergence is very less, that is the bending of the rays are very less. But in the second case, the rays bends very nicely, making a good angle between the parallel ray and the divergent ray. So by these two examples, what we come to know is that it's not about the thickness of the lens we conclude. The thing that we conclude here is that what is meant by the power of the lens. Now children, if we need to find out that from these two lenses, that is from lens 1 and lens 2 in both the cases, which one is more powerful? Of course, the one which is able to bend the rays more, right? So in both the cases, lens 2 is more powerful than lens 1. Let us now see the definition of the power of lens. This is the degree of convergence or divergence of light rays by a lens is expressed in terms of its power. That means just now we saw in the case of convex lens for lens 2 and for concave lens also in lens 2, the how much they converge or how much the lens diverge the light rays which are coming toward it. The more they converge, the better or the more powerful lens they become. So the degree of convergence or divergence of light rays by a lens is expressed in terms of its power. The power of the lens is defined as reciprocal of its focal length, which is given by the formula P equals to 1 by F. Remember this children, maximum students do an error in this particular portion, that is P is equals to 1 by F when F is in meter, or it is equals to 100 by F when F is in centimeter. Okay, you have to keep that in mind, that what is the unit of F chosen or given in the question numerical. Now the SI unit of power should be meter inverse because this is the SI unit of length, or in other terms it is also written as diopter, that is capital D. These things need to be noted children, that convex lens, the power of the convex lens is positive and the power of concave lens is negative. So with this we finish the power of lens, that is the definition of power of lens and the formula for power of lens. Now we will do one numerical based on it. Okay, this is the question. The focal length of a concave lens is 2 meter. Calculates its power. So children, you can see what is given in the question. F is equal to minus 2 meter. Now purposely why I have written for concave lens is that for convex lens we know focal length is positive. For the concave lens only 2 meter is written in the question, minus will not be written. This is the part that you have to do by yourself children during the examination and during solving the question of these type. F should be taken as negative for concave lens. So the formula is 1 by F. Why 1 by F is chosen? Because F is given in meter. So we put the value and we get the value of power to be minus 0.5 diopter. I will show you one more example. If F was given in centimeter, what could be the value? So children, this is an example. If F is minus 20 centimeter, if it is taken minus 20 centimeter, if F is taken minus 2 centimeter, then power is taken to be 100 by minus 2. Why 100 is chosen? Because F is given in centimeter, and then the power comes out to be minus 50 diopter. So if F is given in meter, we choose what? 1 by F, and F is given in centimeter, then we choose 100 by F. That's all. Thank you. So with this we complete the chapter, and please solve the question of the power of lens. Thank you children.